Earthquakes. In the India's northern plains, there are frequent earthquakes in the northeast Himalayas because of the movement of the Indian plate and the Indian plate towards the Eurasian plate. We have vibrations in the form of the earthquake. These vibrations is the rocks in the lithosphere. Lithosphere is very closely packed rocks at the stage of equilibrium. They are at the state of equilibrium. When these rocks are disrupted, the vibrations of the lithosphere occurs. Earthquake is the vibration or oscillation of the earth which is caused by the transient disturbance of the elastic or gravitational equilibrium of the rocks at or beneath the surface of the earth. The scientific study of the earthquakes is called seismology. Now, how or what is an earthquake? When there is a vibration which is observed at the earth, when there is a vibration or there is a oscillation. So, a vibration or oscillation which is observed at the earth due to the disturbance, a transient disturbance of the elastic or gravitational equilibrium. Because of the disturbance in the equilibrium, we can observe earthquake because of there is a disturbance in the gravitational equilibrium of the rocks beneath the surface of the earth. So now what is earthquake? Earthquake is nothing but the disturbance in the equilibrium of the rocks which are present beneath the earth, right? This is a vibration. First, initially there is a vibration or an oscillation is present. There is a vibration or an oscillation of the earth. This is when there is a disturbance of the elasticity or the gravitational equilibrium of the rocks which are beneath the surface of the earth. What are the causes of the earthquake? When natural causes such as the plate movements, volcanic eruptions, subsidence, landslides, meteorite impact, they all cause the vibrations on the top layer of the earth. Anthropogenic causes such as mining, constant blasting, nuclear explosion, reservoir induced seismicity where we construct the dams. So, what are the natural causes? The natural causes are because of the plate tectonics, the plate movements. Then we have the volcanic eruptions, subsidence, and landslides, meteorite impact. What is a asteroid? Is the rocky masses which is present between Mars and Jupiter. When it comes out, it becomes meteoroid. Asteroid, meteoroid. Now, when it enters the Earth's atmosphere and it burns in the Earth's atmosphere, it is called as meteor. When it does not burn completely and it reaches the Earth's surface, it is called as meteorite. So the meteorites impact, and the anthropogenic causes are reservoir induced seismicity, mining, nuclear explosion, or the test. Now, earthquake waves. We have focus or hypocenter is the point of generation of energy, is where the energy is being released below the earth's surface. We call it as hypocenter. So we have focus or hypocenter. Focus or the hypocenter is nothing but the point of release. It is the point of release of the earthquake. Hypocenter, or we call it as the focus. Now, what is epicenter? Is the point on the surface of the earth which is directly above the epicenter. The point which is directly above the hypocenter is what we call it as the epicenter. Now, First is the reservoir induced seismicity. There is a when we have a dam being constructed to hold water, there is a huge weight of water column. We need to analyze the rocks on which the dams are being constructed. They must be very strong. If they are weak, there are continuous shocks. Example: the Koyna Reservoir in Maharashtra. Earthquake, which is due to the plate tectonics. When two plates are converging, there is a violent earthquake. We experience the shallow earthquake, intermediate earthquake, as well as the deep earthquake when two plates are converging. And when two plates are diverging, we experience shallow earthquakes. In the transform plate boundaries also, we experience a shallow earthquake. Interlocking of the rocks try to stop the plate movements. When continent plates are converging, when there is a convergence between the continent plates, there is an interlocking, or we could say that there is a suture zone which is created, which attaches the two continental plates in order to stop the plate movement. The interlocking rock stops the interlocking of the rocks, which stops the plate movements for some time. At one particular location, the energy which is building, which is trying to push energy concentrated and sudden release of the energy which spreads at all the directions. The rocks are interlocked. All the rocks which is present in the lithosphere are interlocked. When there is an energy accumulation of these rocks, and this energy is continuously accumulating, but it could not escape because of the underlying rocks which are interlocked. When the energy overpowers the interlocking of the rocks, there is a release of the energy in all the directions. Epicenter is where the earthquake, the energy is being released. The point is what we call it as the hypocenter, but epicenter is where it is reaching first. Earthquake's focus is felt for the first time. We have lithosphere, we have the shock waves in all the different directions. Earthquake waves or shock waves or energy waves. Earthquake waves. First, we have the body waves. Body waves are classified into the P waves, primary waves, and S waves, secondary waves. These are the earthquakes which is generated from the focus and they move towards the interior of the earth, is what we call it as the body waves. When the earthquake waves are generated at the surface of the earth, they are called as surface waves. Now, what are body waves? When the earthquake waves are generated from the focus and they move through the interior of the earth. Earthquake waves are generated. We have the earthquake waves which are generated from the focus and they move through the interior of the earth. There are two types of the body waves, P waves and then we have the S waves. P waves are the first to hit the surface. They are longitudinal waves. This is the longitudinal waves or oscillating waves. So they are the primary waves or compressional waves. They oscillate back and forth in the direction. So they go back and then the forth. Therefore, when this is the waves, so this is the point of epicenter. Sorry, hypocenter. So when hypocenter is in the interior of the earth, right? Let us take this as the hypocenter. And here we be having the epicenter. Now the waves should travel here. Now how does the waves goes? They go longitudinally, and when the waves are going, the building goes up and then comes down. So they are called as it goes up and comes down. The building goes up and comes down. This is the type of the shaking of the building. This kind of the wave is also called as compressional. So it is like compressing. Such a compressional wave does not cause massive destruction of the buildings. Otherwise, we have the S waves which move like a sound waves or we can also call it as transverse waves, right? This is the movement of the S waves. They also move in the form of the water, which is repelling, the repelling effect of the water. So this S wave, as it is moving like this, it causes the building to shake through its sides. So when the buildings are shaking through its sides, right? So the now when the P waves, when they are moving like this, the building goes up and comes down. So the direction is parallel to the movement of the surface is parallel to that of the waves. But here the waves are going like this, but the building is moving like this, left and right. So this causes a huge distraction. P waves are the first to hit the surface. They are longitudinal waves. They are also called as the primary waves or compressional waves. Right? Oscillate back and forth in the direction which is direction of the propagation, and they depend on the compressibility of the material. They pass through all solid, liquid and gases. Travel like the sound is what we have P wave, compress and expand. S waves is what we call it as the secondary waves, or we have the transverse waves. The oscillation as a wave occurs in the perpendicular to the direction of the propagation. They are perpendicular. The oscillation is perpendicular because it is moving. The when the waves are striking in this direction, the building moves in this direction. Therefore, it is perpendicular to the propagation, and it is dependent on the rigidity of the material. Therefore, it cannot pass through liquid or the gases, and it does not travel in the oceans. Surface waves are along the surface. They are the earthquakes which are generated from the epicenter. We say the earthquakes are generated from the epicenter, right? When an earthquake, such an earthquake which is generated from the epicenter and are confined to the surface of the earth, they are much slower than the body waves but can cause more damage. Example, love waves and Rayleigh waves. So the surface waves which are generated from the epicenter, and the types of surface waves are love waves and Rayleigh waves. What is a shadow zone? Is a zone in the interior of the earth where the earthquake waves are not reported. Right. P waves are not detected between 105 to 145 degrees from the epicenter, which is called as P wave shadow zone. S waves cannot pass through the core as it is a liquid. Outer core is a liquid, and hence beyond 105 itself, we do not have the S waves. So 105 to we be having 145 is when we do not have the P waves, and above 105 is where we do not have the S wave as well. S waves are not reported in S-wave shadow zone. The seismic wave undergo reflection, bending, or change in the speed while passing from one medium to another. So they are undergoing, what are the different types of light which is undergoing reflection, bending, and then we have the change in the speed while passing from one medium to another. This is the main reason which is responsible for creation of the shadow zones in the interior of the earth. By analyzing these recordings, that is the time of arrival, speed of waves, direction of the earthquake waves, we can conclude the nature of the interior waves. We have the shallow, intermediate and deep seated. Shallow is more dangerous, intermediate, and then we have the deep seated. Because when it is a shallow earthquake, it is at the surface, nearer to the surface. The point where the focus is released in the surface, the focus is within the lithosphere. When it is intermediate, the waves as they travel, they become less powerful. So the shallow earthquake waves are more dangerous because they are nearby. The release of the energy is nearby the surface. Intermediate earthquakes 0 to 70 kilometers, 70 to 350 and 350 to 700 till the asthenosphere. It does not go below the lower mantle. Focus within the lithosphere, partial subduction of continent convergence. The distribution of the earthquakes, they are in all the plate boundaries. Most common or intense earthquakes are witnessed in the Pacific Ring of Fire. It's called as a circum-Pacific belt. Right. Mediterranean and Transatlantic Belt, Mid-Atlantic Ridge, East African Ridge. P waves are dependent on the density and the compressibility of the material. It vibrates in the direction of the material because it vibrates in the direction of the propagation. S waves are secondary. See, we have it when the S waves are hitting. This is the waves, right? So this is how the movement of the surface materials happens. Particles vibrate perpendicular to the direction of the propagation. The first to reach is the P waves. They are back and forth longitudinal waves. Second is the surface waves. They travel transverse perpendicular. Third is the surface waves who are having maximum damage because of high amplitude. Travel only when the density and the rigidity does not travel through the liquid and the gas. Intraplate movements also cause earthquakes. Earthquake regions are classified into five zones. The zone where minute earthquake, zone 5, very intense. Zone 1 is minute earthquake, and zone 5 is very intense. In India, there is no zone 1 because everywhere it is possible. Focus and epicenter is used only in the plate tectonics. Magnetic lines at the poles are vertical, not horizontal. Therefore, they have interaction with the solar winds. Now we have the shadow zones, right? When the waves are traveling from one medium to another, there is a change in the direction. When it is originating here, it travels, right? 105 is 10 when the then it is originating from one medium to another. It is having reflection. When the waves are traveling from one medium to another, there is a change in the direction. From mantle to core, it is going rarer to denser medium. The direction is changed again denser to rarer medium, right? Because the outer core is liquid. The P wave here, it goes in this direction, whereas the S wave, it does not go in the core itself. Therefore, S waves are found only from 0 to 105, whereas P wave are found from the shadow zone is 105 to 145, right? The shadow zone of the S waves is 105 to 145. It does not travel through the liquid. No direct S waves are received here. Geomagnetic reversal is the flip of the north and the south pole. Geomagnetic excursion is the field just glitches but ends up in the same direction where it starts. Now we have the earth, right? We have the magnetic field. The field is just glitch in the sense there is a sudden pause or there is some distraction, right? Glitches is what, when they are having the glitches, it is called as excursion. Geomagnetic excursion is when there is a glitch, and geomagnetic reversal is the flip. Geomagnetic excursion is a excursion. Excursion is when there is a glitch. Dynamo theory. In the physics, the dynamo theory proposes a mechanism by which a celestial body, such as the Earth or a star, generates magnetic field. When a celestial body generates a magnetic field, such a mechanism is dynamo theory under physics. South Atlantic anomaly. We have Atlantic, right? Atlantic is between the Americas and Eurasia, Africa. Why earthquakes are hard to predict? Tectonic plates are riding on a hot, partially molten layer called as the Earth's mantle. This causes the plate to spread very slowly. The mantle is very viscous. That is why the plates spread at a very slow rate of 1 to 1.5 centimeter per year. But these tiny movements are powerful to cause the deep cracks in interacting plates. Right? We say that the tectonic plates which are on the asthenosphere, which is highly viscous and plastic in nature. Due to this, the plates are having a resistance. That is why the plates move very slowly at a rate of 1 to 1.5 centimeter per year. But these tiny movements are enough to cause deep cracks. There are cracks in the interacting plates, and in unstable zones, the intensifying pressure may trigger the earthquake. Even the small movements are enough to cause deep cracks. in the interacting plates and the unstable zone where pressure is intensifying. Measurement of the earthquake is through seismograph is measuring the earthquake. To know the magnitude of the earthquake, we go for the Richter scale. To know the intensity of the earthquake, the amount of damage it is felt, we are going for the Mercalli scale. So we have seismograph, there is a spring weight and a pin and a rotating drum in horizontal motion. The surface waves, we have the amplitude and direction is very high. This is called, the graph is called as a seismograph. So when, because the surface waves are observed in the surface, their amplitude and even the duration of occurrence is also very high for these waves, whereas the P waves and then the S waves are very small. We have the surface waves which is having the amplitude and duration very high. The graph is called as a seismogram and the reading is what we call it as a seismograph. So the graph, right, x-axis, y-axis, we have a graph. This graph is called as a gram and the reading over here is what we call it as a seismograph. We should not be confused. The graph is called as seismogram and the reading or the recording is what we call it as a graph. Magnitude of the earthquake versus the intensity of the earthquake. In a magnitude of the earthquake, the measure of the amount of energy which is released. The severity of the earthquake is the intensity of the earthquake. It is measured by the Richter scale and it has a range of 1 to 10. Objective, it is a logarithmic scale. Each unit is being 10 times and for each 1 and 2 there is a 10 times shift in the magnitude and 32 times shift in the energy. It is a subjective assessment of visible damage which is caused during the earth. It may decrease away from the epicenter. It is a subjective measure and the measure by modified Mercalli scale which has a range between 1 to 12 is a Mercalli scale. The intensity is more near the epicenter and decreases away from the epicenter. Now, measurement of the earthquake. We have seismograph, which is used to measure the earthquake waves recorded. The recording of the waves, and then gram is nothing but the record produced from a seismograph is what we call it as a gram. Intensity. The intensity of the earthquake can be reduced by preventive measures. The places where it does not shake are the first to fall because rigidity is not accepted in the earthquake. Intensity measured by the visible damage which has been caused. So the intensity we have linear scale and for magnitude logarithmic scale. The most famous earthquakes are 2004 Indonesia where it had 9.1, 2011 Japan 9.1 Richter, 2001 Gujarat 7.7 Richter scale. Important earthquake zone is the Mid-Atlantic Ridge, Mid-Oceanic Ridge. This is what Alpine Belt, Circum-Pacific Belt, Ring of Fire. World's most earthquake-prone regions are the places where geomorphologically active belts are present. Effect is a loss of life, infrastructure damage, flash floods, fires, and then deformation, transform plate boundaries. Example is the San Andreas fault. Then we have landslides and tsunamis. What is a tsunami? Is a Japanese word which means the harbor waves. They're also called as seismic sea waves. Now, what are tsunamis? Is a Japanese word. Harbor waves. So we have the tsunamis is a Japanese word which is meaning the harbor waves, whereas they are also called as the seismic sea wave. Causes of the tsunami generation. It is generated due to the vertical displacement of a column of the sea. Horizontal, not horizontal, vertical displacement. This is the here and this is the here. 1 and 2. From 1 and 2, not horizontal. 1 and then 2 is horizontal. Just moving up and down is not causing tsunami. The vertical displacement of the column of a seawater, it is due to the earthquake along the normal or reverse fault. Volcanic eruptions along the seafloor or the coastline. We have landslide subsidence along the oceanic floor. So, large meteorite impact on the ocean. What are the stages in the existence of tsunamis? Is generation. Any reason that is causing the vertical displacement of the water. The vertical displacement of the water is what we have the tsunamis. Propagation in the deep water waves. The speed of the wave will be very high and the amplitude will be very low. Therefore, the tsunami will not be visible in the open ocean. Now, vertical is you are also moving the location, right? Propagation in the shallow waters. As the waves approach the coast, the depth of the water decreases and the speed of the water decreases, the amplitude is going to increases. When they are in the deep waters, we will be having the speed is very high, right? The amplitude is very low. The speed, amplitude, and then the depth. Speed and then the height, amplitude. The speed is very high, but the height is low when they are in the deep waters. The speed is high, whereas the height is low when they are in the deep waters. When they are in the shallow waters, the speed is low, height is very high, and we also have the depth of the water decreases. The speed is decreases and the amplitude is high. Due to the low speed of the water, water is piling up near the coast, resulting in the generation of very high waves near the coast is called as a shoaling effect. Because of the shoaling effect, right? First, initially the speed is very high and the height is amplitude is very low when they are in the deep waters. When they are nearing to the coast or when they are nearing to the surface, the speed reduces, but the height starts increasing. This is because as the speed got decreased, the water gets accumulated and forming pile of water, and this effect is called as a shoaling effect. Then we have a landfall. Will all the earthquake result in tsunami? No, an earthquake which is greater than 7.5, there is a tsunami which is destructive. Most of the earthquakes are in shallow, great at subjective zones. Tsunami causes upliftment of the subsidence, collapse of the volcano. Now, this is the ocean. If it moves up and down, right? The ocean moves up and down. Any event in the ocean floor is what we have the vertical displacement. Water goes up and down. This sends energy in all the direction. Therefore, if no vertical displacement, then no tsunami. Only when you go up and down, there is a energy which is going to be transmitted, right? So if earthquake is in a transform fault, it moves horizontally, there is no tsunami. Up and down only results in the energy transfers, and this energy transfer causes the tsunami. Tsunami occurs in normal faults and reverse fault and not in the transform fault. Example, in Indonesia, 2004 earthquake, the normal fault tsunami. 2012 earthquake is a transform fault in Indonesia and Eurasian plate tsunami. 2018 is no recording in the tsunami, the seismograph, but vibrations due to the collapse of the Krakatoa volcano and tsunami. Because of the vibration due to the collapse of the volcano has caused a tsunami. Island collapses, water displacement. Subsidence of the land is where tsunami occurs. So when there is an island collapse, when there is earthquake, and when there is subsidence of the land, we be having the tsunamis, right? Stages in the tsunami. Deep generation, speed is high, amplitude is low. When in the shallow, the speed is low, therefore accumulation of the water and amplitude is high. The speed of the tsunami is directly proportional to the depth. The speed is high when the depth is high, and the speed is low when the depth is low. Amplitude is indirectly proportional to the depth. Therefore, tsunamis are not detected in open oceans. It will impact any ships in the oceans. It will not impact. The shallow water is where depth and the speed is decreases. During the landfall, the tsunami will be falling on the land. It has a maximum amplitude. Shoaling effect is nothing but the piling up of the water in the coastal region, which results in the drastic and sudden increase in the height of the wave. When it goes back, it takes all the waters along the coast, and then the water is going to recede back. We have the Pacific plate, the Philippines plate, North American, Eurasian plate. Here there is a zone of the volcanoes, and the last stage is landfall.